We are starting with the third type of reactions, which are shown by the alkyl halides and the aryl halides both. These are the reaction with metals. Okay, and we will take it one by one. So number one, we start with reactions of alkyl halides. Reactions of alkyl halides with metals. Now again here there are two reactions that we have to take up. The first one, A, is the formation of the Grignard reagent. This is the formation of the Grignard reagent. Alkyl halides, let's take the general form first of all. Alkyl halides, when they react with magnesium metal in the presence of dry ether, it reacts and magnesium enters in here to form a compound that is RMgX. This compound is called the Grignard's reagent. Grignard reagent can also be called the alkyl magnesium halide. Alkyl magnesium halide. So Grignard reagent is what? It's an alkyl magnesium halide, RMgX, right? So we can take one example. Let's say we have CH3CH2Br bromoethane plus magnesium in the presence of dry ether, right? So do the same thing, bring in magnesium here. So what compound will be formed? CH3CH2MgBr. That's the Grignard reagent. If you have to name it, how will you name it? The group here is ethyl. So this will be ethyl magnesium bromide. Okay, so this is how Grignard reagent can be prepared, right? Now another important thing about the Grignard's reagent is the bonding in it. When you see the Grignard reagent RMgX, the bond between the alkyl group and magnesium is a covalent bond. It is a covalent bond, but certainly there is some polarity, because magnesium is a metal and R is a carbon atom. So carbon is more electronegative as compared to magnesium. So the R part will take up a partial negative charge and magnesium takes up positive charge as expected. So electrons are withdrawn towards the alkyl. So this bond you can say is a polar covalent bond. And the bond between magnesium and halogen, undoubtedly the halogen will withdraw electrons towards itself, making itself negatively charged. So the bond between magnesium and halogen is an ionic bond, right? So the bond between magnesium and halogen is ionic. The one between the alkyl part and magnesium is a polar covalent bond. Now one more thing that you should know is that the Grignard reagent RMgX, okay, these compounds are also called the organometallic compounds. These compounds are referred to as the organometallic compounds. And you can understand the reason why organometallic, because a metal is bonded to carbon directly. Organo is for carbon and metallic is for the metal. So when metals are directly bonded to carbon atom, such compounds are known as organometallic compounds, right? So Grignard's reagent is an organometallic compound. Grignard reagent is very reactive. RMgX. It's a very reactive compound and it reacts with the, even traces of moisture if present. So if you have moisture, right, and water, which can be, taken as H plus and OH minus. So Grignard's reagent reacts with a source of H plus actually. It should be a source of H plus ions, protons. If you see the charge separation, the R part is minus and the mgx part, the entire mgx part takes up a partial positive charge. See, magnesium valency is or charge is +2, halogen is -1. Mg is +2, X is -1. So overall how much is left? +1. So effectively the MgX part takes up a positive charge and the alkyl part takes up the negative. So the H plus from water attacks the R minus and it forms what? RH. Plus there's a byproduct which is MgOH. Now what is this RH? This is an alkane. So Grignard's reagent, when it reacts with water or moisture, it forms an alkane. And not just water, it can react with, water is one that I've written, it can react with alcohol, CH3CH2OH. It can even react with amines, RNH2, because it can react with, it said that it can react with any source of H plus ions. Any source, any substance that can give it H plus ions, it will react with. So it can react with water, alcohol or amines. And therefore, it's a very important precaution which is to be taken while preparing the Grignard's reagent. And what is that? Grignard reagent should be prepared under anhydrous. Anhydrous means without water. Grignard's reagent should be prepared under anhydrous conditions. Otherwise, what will happen? You've just seen it. What will happen? It will take up water or moisture. And what will it take up further from water? H plus, and will be converted into an alkane. So Grignard's reagent, if you are preparing, it should be prepared under anhydrous conditions, moisture-free conditions. The second reaction of alkyl halides with metals is another name reaction which is called the Wood's reaction. And Wood's reaction is, if you remember, it is used to prepare alkanes. It is used for the preparation of alkanes, especially the ones containing an even number of carbon atoms. So Wood's reaction is another reaction of alkyl halides with metals. Let's see, take an example. I take CH3Cl as an alkyl halide. In Wood's reaction, 2 moles of an alkyl halide is made to react with sodium metal in the presence of dry ether. So an alkyl halide, 2 moles, reacts with sodium metal in the presence of dry ether. Now what you have to do is remove the halogen and see how many methyls are left behind now. There are 2 such methyl groups left behind. Connect the 2 methyls. So when the 2 methyls, they connect to each other, they form an alkane. Which alkane is this one? Ethane. Plus the 2 chloride ions and the 2 sodium atoms, they form NaCl as the byproduct, right? So the chloromethane alkyl halide contain only 1 carbon atom, because but then we took 2 moles of it. Therefore the alkane which is formed contains 2 carbon atoms, and so you can see here that we have got double the number of carbon atoms. Let's take one more example. Suppose I take CH3CHBrCH3. This is 2-bromopropane, right? And same conditions. So I have sodium metal and in the presence of dry ether. See, the alkane contains how many carbon atoms? The name is, what is the name of this? This is 2-bromopropane. So this contains how many carbon atoms? 3. 3 is odd number, isn't it? Now when the reaction will take place, it will be 2 moles of this with 2 moles of sodium metal. And what you have to do to write the product is remove the halogen and connect 2 such groups. Right? Connect 2 such groups with each other, because you have 2 such groups now. Remember to connect the 2 such groups from the center carbon, because the halogen is removed from the center carbon. So they will connect through the center carbon only. Right? So I'm writing the first CH3CHCH3 group. And I'm taking one more such group, CH3CHCH3. And from where to connect it? It is to be connected through the center carbon. So both are now connected via the center carbon. So this gives us our alkane. If you count the number of carbon atoms, it's 1, 2, 3, 4, 5 and 6. So even number of carbon atoms, the number of carbon atoms got doubled, right? And if you write the IUPAC name of this compound, The longest carbon chain is of 4 carbon atoms, and there are 2 methyls on second and third position. So this is 2, 3 dimethyl butane. 2,3 dimethyl butane will be the product formed. So keep this thing in mind. When you double the number of carbon atoms, be careful. You have to connect the groups through the carbon from which the halogen is removed. Don't just connect it from the terminal ends, right? The two such groups are to be connected through what? The center carbon. Why in this case? Because the center carbon is the one from which the halogen has been removed. So this is how Wood's reaction can be used to prepare alkanes containing an even number of carbon atoms. And now the second category that we take here is the reactions of aryl halides. Reactions of aryl halides with metals. Even the aryl halides can react with metals, and there are two reactions to be taken up. A is a name reaction. It's called the Wurtz-Fittig reaction. It is the Wurtz-Fittig reaction. Let's see what happens in the Wurtz-Fittig reaction. Here, 1 mole of an alkyl halide, let's say CH3Cl, is taken along with second mole of an aryl halide. So what we have to take is 1 alkyl and 1 aryl, right? Wurtz gives us the alkyl and Fittig gives us the aryl part. So from Wurtz I take 1 alkyl and from Fittig I take 1 aryl. So 1 mole of an alkyl halide and 1 mole of an aryl halide and the same sodium metal in the presence of dry ether. Okay, and what happens is both the halogens will be removed and the alkyl and the aryl ring, they are going to join to each other. So what we get is benzene with a CH3 plus NaCl, plus we will get 2 moles of NaCl. So what is this? This is toluene. So what we have got is an aromatic hydrocarbon. So depending on which alkyl group you take, you can get different types of aromatic hydrocarbons by this reaction. Let's take one more example. Suppose this time I take 2-bromopropane and make it react with bromobenzene in the presence of sodium metal and dry ether. So which reaction will this be? This will be regarded as the Wurtz-Fittig reaction, because one is an alkyl halide and 2 is an aryl halide. And what happens? The two halogens will be removed and the alkyl and the aryl ring are going to join. Again, be careful. The alkyl is to be connected through the same carbon from where the halogen is removed. So which compound will you get is benzene will get an isopropyl group, which is CH3CH3. See, linkage has taken place from the center carbon. Center carbon, the same from which the halogen was removed, and you get the usual byproducts as NaBr. So what is this compound? This compound is isopropyl benzene. Isopropyl benzene in the common system is also known by the name cumene. So what we have prepared is isopropyl benzene or cumene. So these were two examples of the Wurtz-Fittig reaction. And now let's move on to B, the last reaction of aryl halides with metals, which is known as the Fittig reaction. Now, as this is the Fittig reaction, and remember Fittig means what? Fittig means we have to take the aryl halide. So, in Fittig reaction, we will take 2 moles of the aryl halide itself. So, we take 2 moles of an aryl halide in the presence of sodium metal and dry ether. And same thing happens, the halogen gets removed and the two aryl parts now join with each other. So, the two benzene rings, the arenes, they join with each other and you get the usual byproduct, that is NaCl. The compound formed is known as biphenyl or diphenyl, right? So Wurtz-Fittig reaction was 1 alkyl, 1 aryl, but Fittig is entirely aryl halides. So 2 moles of aryl halide, sodium metal, dry ether gives you diphenyl or biphenyl.